Hi, we skipped over these examples in class, and I said that I was going to make a video and just have you watch it because realistically, they're kind of very similar to the ones we did. So this is that. This first example gives a table of values, so we don't actually have the graph. It says find the area under the graph of y equals f of x and above the x-axis on the interval from 2 to 10, given the following data, and using a left Riemann sum approach. Let n equal 4. N, remember, is the number of subintervals. So if we notice, this would be our first interval, second, third, and fourth, but they are of unequal width, and that's okay. This first width is 1, the second width is 2, 5 to 8 would be 3, and 8 to 10 is 2. Because we are asked to find a left sum, I am going to pick the y values that start on the left and not include this last one. So our first width is 1 times the height of y, which would be 5, plus the second width of 2 times the height of 7, plus 3 times 11, plus 2 times 10. If I go through, type this all into my calculator, and as long as I'm double checking my work, you should get that the sum here is 72. Let's look at another one. Use a left Riemann sum with one subinterval to approximate the area between the curve and the x-axis from 0 to 2. They want us to do a left sum with one subinterval. So realistically, we're starting on the left side of the curve and we're making this rectangle right here, and that's our, sorry, I didn't really think I was using the yellow. This is the area of interest. And even though it looks obviously to us that it's a super underestimate, that's okay. It's still correct. It's one subinterval. So we have a width of 2 and a height of 1. Our estimate is 2, and it would be, I don't know, units, I guess, because they don't really tell us anything about this function. We're just going to say 2 units. Same curve. They want us to use a left Riemann sum with 2 equal subintervals. Okay, so we draw our rectangles in here. 1, 2. Those are my 2 subintervals. They are the same width of 1. And this first one I can tell is just the square right here. So 1 times 1. And the second one is either I would maybe kind of estimate this, or I know my function. So I am looking at 0.5 times 1 squared plus 1 to find this y value right here. 1 squared is 1. 0.5 times 1 is 0.5. 1 plus 0.5 is 1.5. So I have 1.5 plus 1. This estimate is 3.5 units. We notice it is more accurate because we have shaded in more area. And then let's look at the last case. They want us to find a right Riemann sum with 2 subintervals to approximate our area. So in this case, I'm drawing my rectangles where the right corner hits the function. And I am looking for these 2 areas. I know my width is 1 times a height. We just found this is 1.5, right? Because that's f of 1, or v of 1, excuse me. And I can see very clearly that this height is 3. So I'm going to say plus 1 times 3. 1.5 plus 3 is 4.5 units. And this is probably an overestimate. Not probably. This is definitely an overestimate, right? And that's okay, because that's really it. And now that I'm looking at this, I realize I made a mistake. And hopefully you're sitting at home thinking, oh my gosh, Ms. Wissing, how are you so, well, I would not let you guys say you're so dumb, so I shouldn't say I'm so dumb. 1.5 plus 1 is not 3.5. Oh my goodness. 2.5 units. Okay, sorry about that. was not obviously paying attention. So these were the examples we skipped in class, and I thought they were fair to skip. And we had been working on this problem about TikToks, and we will come back to it because remember, right at the end of class, we kind of made a mistake, and that is okay. We'll start with this on Monday. Have a great rest of your day.